Hi, year eights. So today what you're going to do is continue to work on calculating the gradient of a graph or from a table of values. So this is the second lesson. So just a couple of reminders or a couple of recaps. So we explored different ways to calculate the gradient, or remember we called that the slope. So remember that the gradient is a measure of the slope, and we can have four possible things that happen when we calculate a gradient. We can have a positive gradient, a negative gradient, a zero gradient, or an undefined. And it'd be really good if you remembered those. Okay, so let's just quickly do the positive one again. So here's a quick Cartesian plane, there and there. Now, we'll draw some lines. So positive gradients, as x increases, the y values increase. Negative gradients, as x increases, the y values decrease. Zero gradients means that the y values don't change. They stay the same all the time. And undefined the gradient doesn't make sense because x doesn't increase. All right, so we've explored many ways or many different ways of calculating gradient, and we'll continue to use these methods today, including one new method, which is actually the same as others, but anyway, we'll get onto it. Right, so for this particular type of question, what they do is they give you 2 points, and they ask you to find the gradient of the line joining those 2 points. So I think the first way we'll use is this rise over the run method. Okay, so in this box here, I'm just going to draw a quick Cartesian plane. And not to scale, I'm going to plot these 2 points. So one of the points is 0, 2, 3, 4, 5. So here is 0, 5. Now I'm going to plot this point here, which is 2. So here's 1, here's 2. And -1, -2, -3. So here's the second point. And what we want to do is we want to plot, or not plot, but write the equation of the lines. So let's draw the line connecting the 2 points. There it is there. So the first thing hopefully you can see is that this is a negative gradient. Okay, it's very important to note that as the x values go up, the y values are coming down. All right, so we explored the method where what you do is, what color should I use now? Maybe green. Is that you start from this point here and you always move to the right, and then you're going to move either up or down. And if you move up, you're talking positive. If you move down, you're talking negative. Okay, so we're going to move down at this point to meet this one. All right, now we're going to look at this value here, which is the run. Okay, and we can see here that it's got a distance of 2. Back to blue. Okay, and now what we'll do is look at the rise. So we're at the y value 5, so we're going 5, 4, 3, 2, 1, 0. So that's 5 units to there. And then -1, -2, -3, that's another 3 units. So this is 5 and 3. So the rise is going to be -8. Okay, so again going out and down. All right, so if the gradient equals the rise over the run, then what we're going to do is take this -8, which is the rise, divide it by 2, and we're going to say that the gradient is -4. All right, so that's a familiar technique. All right, that's what we were doing with the graphs yesterday, except the graph was produced for us. This time, they only give us 2 points. Okay, the next method is the also familiar table of values. So x and y, and what we do is we just put the 2 points into the table. All right, so I'm going to put this point in first, 0, 5, and this point in second, which is 2 and -3. Now recall that the definition of the gradient is as x increases by 1, we're looking at the change in y values. Now x isn't increasing by 1, but what we can do is just edit this table ever so slightly by putting a 1 in there. And then we can have a look at the change here. So I can see from 5 to -3, the change is 8. So this is going to be 4 units difference. So this 5 here what we're going to do is make it go down to 1. So I can see here that as x goes up by 1, the y values go down by 4. As x goes up by 1, the y values go down by 4. So the gradient is -4. So that looks to be the easiest for the moment because it doesn't require you to plot and draw the graph up and do the rise over the run. Okay, this seemingly looks really complicated, but it actually is just the same as this and this method here. Okay, so this is a y2 take away y1 over x2 take away x1. Now, what does this mean? Well, what we do here, y2 take away y1 calculates the difference in y values. Now, you can see here that the difference in y values, I take this y value here 5 and this y value here -3. The difference would be 5 take away -3, and it's going to calculate the value as 8. Okay, so what this does is it just calculates the change for you. Here you have to do it visually or you have to count and look, but this one will do it kind of for you. Okay, so the way I like to do this one, or teach this one anyway, is we write up our points that we're using and we call this x1, y1, and we call this point x2, y2. Now, by the way, this could be the other way around. So you could, if you want, do 0, 5 as x1, y1, and do 2, -3 as x2 and y2. What you can't mix up is the numbers. So this is coordinate pair 1, this is coordinate pair 2. Alrighty, so I'm going to stick with what I originally chose. And now all I'm going to do is follow the formula. Gradient equals. All right, the y2 value. Now that's going to be 5. The y1 value, so it's going to be take away -3 over. We take the x2 value, which is 0, and we subtract the x1 value, which is -2. Now that's given us 5 subtract -3 is 8. 0 take away 2 is -2. Now, a positive divided by a negative is a negative, and 2 goes into 8 4 times. The gradient is 4. So you can see that there's 3 different methods, and different methods will suit different problems. Like you might look at this one and go, oh, I think table of values is the best way. Or I think this is the best way. So you're going to sort of start to use a particular method to calculate gradients, and really it's my job to show you some of the different methods. Okay, so this one here, we've got 2 points, -4, 6, and 2, -6. So let's try and use table of values. Let's try using that one. Okay, so we've got x, y, and we've got -4, 6, and 2, -6. Now, you can see here that the slight problem with the table of values is that because these are so far apart, it's not just one single value that we would put in between two values. This is actually a change of 6 units. So we've got to put 5 more units, I think, in between -4 and 2, and then split up the 6 and -6 somehow. So for this one here, I would not use the table of values method. All right, so let's just try the gradient equals y2 take away y1. We'll try this method second. So we're going to go -4, 6, and 2, -6. We're going to put x1, y1, x2, and y2. Okay, let's use the formula, gradient equals. So it's y2, which is -6, take away y1, which is 6, over x2, which is 2, and we're going to subtract -4. Okay, -6 take away 6 is -12. 2 subtract -4 is 6. Okay, 6 goes into -12, -6 times. So we're going to suggest to you that the gradient is -6. No, that's wrong. Lucky I caught that before I hit stop. 6 goes into 12 2 times. The gradient is -2. All right, so let's do it the final way by calculating the rise over the run. So again, what we do is we draw up a Cartesian plane. And -1, -2, -3, -4. 1, 2, 3, 4, 5, 6. 1, 2, and 1, 2, 3, 4, 5, 6. -6. Here it is here. Okay, so again, the way we do this is we choose this point here and we always move to the right. So we're going to go over to the right and then down to meet that other point. Notice how I snuck through 2 there. Okay, so let's look at the run. We go from -4 to 2, so that's going to be 1, 2, 3, 4, 5, 6. So the run is 6. And notice that that matches x2 take away x1 down here. All right, this value here is going to be the change in y values, and because we're going downwards, we're going to list that as negative. So that's going to be 6 to here and another 6 down to here, so that's going to be -12. So our gradient is the rise, which is -12, over the run, which is 6, which is -2. Okay, so hopefully you can see that, so for this method here, I think the formula is probably the easiest method because it saves you having to do the graph and do the single counting. What's hard about the formula is that it uses negatives and positives and things like that, and that's a little confusing for some students, okay? The table of values method just straight up is too hard or too much work. It just doesn't work for this particular problem. So what you're going to do now is you're going to move to 9D and you're going to do question 10, which are questions just like this. They give you 2 points. And then some harder questions which get you to calculate gradients from a graph, I think, again. Then, after that, you're going to work on the progress quiz and the chapter review multiple choice questions 1 to 6, just to kind of bring together 9A through to 9D so far. So you're ready to move on with the next part of this unit.